Class number 4, separable equations. So far we have seen first order linear D's, but now let's look at nonlinear D's. So first case is separable equations, and I will tell you what it is. So to give you motivation, suppose we have such DE. It is first order. And what does this resemble? Well, the left-hand side is h of y, where y is a function of t, and then y prime t. That's the left-hand side, right? What does that resemble? Well, it looks like this. If we have composition of f and g is a function of x, and then if we take the derivative with respect to x, we take the derivative of outside function, and then we multiply that by the derivative of inside function, right? So compare this with that. If I can find big F of y so that big F prime is h of y, if I can do that, then I can replace this by big F prime of y of t. Then this exactly resembles that, right? F prime of y times y prime of t, that exactly looks like this. So it resembles chain rule in the differentiation. Chain rule. So if the first order DE, any first order D can be written like this, and if f of ty looks like g of t over h of y, or we can say by taking 1 over h of y as a separate function, we can say ly times g of t. So if it is a function of y times function of t, so the variables are separated. If we have such dE, that dE is called separable. So how do we solve a separable equation? We write the separable equation in this form, and then we find f such that big F prime is h of y, and then use chain rule. So how to solve? We have this. So that's what we had. We had h of y dy dt equal to g of t, and suppose big F of y prime is h of y. Suppose that we found big F such that big F prime of y is h of y, then this can be written as big F prime y times y prime t. That is this, and I wrote that as y prime, right? Which is the derivative with respect to t of big F of y of t by the chain rule. So the left-hand side looks like this, which is here, equal to g of t. So we can convert the original dE into this form, right? Where big F of y is an antiderivative. Since big F prime y is h of y, h is the derivative of big F. So big F is an antiderivative of h of y, i.e. big F of y is an antiderivative of h of y with respect to y. That's big F. Okay. So when we do that, we will get various constants, but since I want one antiderivative, I can take constant c to be 0. So from there, so see, that was our original equation, and then we change that into this by finding big F of y like this, and then here we integrate, and then we integrate this with respect to t. Okay, so when we do differentiation and then integration, then we get the original function back with constant c, and then we will move that constant to the other side, and integral g of t here, the integral g of t is there, g of t dt is here. Okay, and then we solve this equation for y, because we're looking for y of t. Well, I made this thing messy, so let me re-explain for you. So h of y dy dt equal to g of t. This is, the left hand side is big F of y of t derivative with respect to t. From there, we assume that big F prime of y is h of y, i.e. big F of y is antiderivative of h of y with respect to y. Okay, and then we take the integral with respect to t. From there, we get big F of y of t, and when you do differentiation and then integration, you get plus c, right, from integration, and then integral g of t dt, and then we move this c to the right, so that's another arbitrary constant, and then we solve for y of t. In here, we solve for y of t. So that's the main step in solving separable equations. So for example, number 3, dy dt is d squared over y squared. So that's t squared over y squared. So the variables are separated, so it is a separable equation. Yeah, so write that in standard form. So standard form is hy dy dt equal to g of t, and we write the left hand side as d dt big F of y of t, right? Where big Fy is antiderivative of h of y dy. So if I write this in standard form, I get y squared dy dt equals to t squared. So the left hand side is, it is derivative of y cubed over 3 with respect to t. Right? Because y cubed over 3 is antiderivative derivative of y squared with respect to y by taking c to be 0. So this is our big F of y. So that goes into there. Okay, so we integrate this with respect to t. dt, dt. And from the left-hand side, we get y cubed over 3 plus c. This c is variable of constant of integration, right? When we do the antiderivative, when we do the indefinite integral, we get constant c, right? Equal to, from here we get t cubed over 3, and then we will get another constant, and you may collect them together, multiply by 3, then we get y cubed equal to t cubed plus another arbitrary constant. Okay, and then solve for y. So y of t equal to cube root of t cubed plus c. Okay, so we solved this separable D. Next example, B. Is this separable? Yes, it is. This is e to the y dy dt equal to t plus t cubed. Separable. So that is g of t, and this is h of y. Since antiderivative of e to the y dy is e to the y plus c, and we want one big F, so we take c to be 0. So that is our big F of y, right? So this is equal to derivative with respect to t of e to the y. Okay, so we do the integral with respect to t. Okay, so from there we get e to the y plus c. From here we get t squared over 2 plus t to the 4th over 4 plus some other constant, c1. So e to the y is t squared over 2 plus t to the 4th over 4 plus arbitrary constant c, which combines c and c1. Okay, and then we can solve for y. Y of t is ln t squared over 2 plus t to the 4th over 4 plus c. Okay.